Hi everyone, today we're going to study interest compounded continuously. First, let us recall interest can be compounded yearly, semi-annually, quarterly, monthly, daily, hourly, minutely, and even every second. When interest is compounded infinitely many times, we say that the interest is compounded continuously. For interest compounded continuously, we say that if we invest a principal P at an interest rate R per year, compounded continuously, after T years, the final amount A will be given by this formula. Capital A equals capital P times the constant E, and this is raised to a power which is a product of R times T. Take note that this E is a special constant that is equivalent to 2.71828 and so on. We can get this number directly from the calculator. Let us see example 1. If $3,500 is invested at 9% compounded continuously, what will the future value be in 4 years? First, let us write our formula here, and then let us list the given of the problem. Beginning with the principal P, and that is the 3,500, followed by the rate denoted by small r, and that is the 9%. We convert this 9% into decimal. First, let us drop the percent sign and divide the number 9 by 100. And the quotient will give us 0.09. Next is the time denoted by T, and that is 4 years. Now we are ready to use our formula. Let us write it again in here. Then let us do the substitution. So we have this capital A equals, the P is now changed into 3,500 times the constant E that is raised to the product RT. The R is now changed into 0.09 times the time, which is 4. To simplify further, let us begin by taking the product of this exponent. 0.09 times 4 will give us 0.36. Let us use our calculator to get this value, and the answer will be 1.43333. This decimal we will multiply to 3,500, and the product will be 5,016.65. This is our A. This is the future value. Of course, we will attach our dollar sign, and this is our final answer. Let us see this example 2. If an amount is invested at 7%, estimate how long it will take to double. For our solution, let us bear in mind that we are looking for the time. Since we are estimating the answer, we really do not care how often the interest is compounded. Let us say the interest is compounded continuously. Then the formula A equals capital P times the constant e raised to RT becomes like this. To double the amount, it means to double that principal, so the A is now changed into 2P equals the same right side. We can see here that both sides have this letter P. So we can divide this equation by the P to simplify. So the next equation will be 2 equals the constant e raised to the exponent RT. In our given here is the rate, which is 7%. And we know that the 7% is equal to 0.07. We can now substitute this decimal for r in our equation. Let us continue on this side. So we can write now 2 equals the constant e raised to the product 0.07 times t. In this case, only the t is the variable. To solve for t, what we're going to do is to take the natural logarithm of both sides. So we will write ln of 2 equals the ln of this e raised to that product 0.07 times t. I hope you still remember that ln of e raised to x can be simplified into x. So we can simplify this equation further by writing ln of 2 equals this exponent now, the 0.07 times t. We can get the value of ln2 in our calculator. We want now to isolate t. We will divide the equation by the coefficient of t, and that is the 0.07. So on the left side, we will see ln of 2 all over 0.07 equals the right side. This constant 0.07 is now cancelled out. Only t comes down. Using our calculator, the value of t can be derived, and it is equal to 9.902. We can round off our answer and we can write 10. And the time here is in terms of years. It means to say, for an amount that is invested at 7%, it will take about 10 years to make it double. This is our final answer. Example 3. If an amount is invested at 7% compounded continuously, what is the effective interest rate? We're going to use this formula. Capital E equals small e raised to r minus 1, where this capital E is the effective rate. Small e is the constant 2.71828 and so on, and the r is the rate. Given our rate here as 7%, we can show this as 7 over 100, and finally in decimal this is 0.07. We will now substitute this value of r in our formula. So we have E or capital E equals small e raised to 0.07 then minus 1. We can use calculator to simplify this value, and that will be 1.0725 minus 1, and the answer is 0.0725. We can convert this into percent, so that will be 7.25%. This is the effective rate.